Good evening, everybody. Good evening. This is Exploring the Solar System with Telescopes. What I'll be talking about is giving you a very brief reminder of the 400 years since the telescope was invented, having a look at some of the first views of the solar system using telescopes and some of the latest views with the latest telescopes we have, and then asking what is next in terms of the development of telescopes into the future. So it started more than 400 years ago. Galileo didn't necessarily invent the telescope, but he was one of the first to point the telescope to the skies, to look at the stars and look at the planets. Since then, telescopes have been getting ever bigger. Instead of using lenses, we now tend to use mirrors. And in the last century, the telescopes have got huge mirrors, 2.5 meters in diameter, or the Hale telescope with a mirror 5 meters in diameter. That was the largest telescope in the world when I was born, and it was also the largest telescope in the world for most of my adult life, though it has now been superseded. And of course, we now have not only telescopes on the ground, we also have telescopes in space, such as the Hubble Space Telescope and the James Webb Space Telescopes. And in the next few years, we are going to have monster-sized telescopes being built here on the ground in various places around the world. In particular, one that is called, rather unimaginatively, the Extremely Large Telescope. They need to find better names for these things. But this is going to be a telescope with a mirror about 40 meters in diameter. Absolutely huge. So what happened 400 years ago? Well, Galileo turned his telescope on the skies and he saw a number of different things, including when he looked at Jupiter, he saw, quote, 4 stars which wander around Jupiter as does the moon around the Earth. And in his notebook, he made a note of there's Jupiter and there appears to be 4 stars. He wasn't sure what they were, but these stars appear to rotate around the planet, telling us that the Earth is not necessarily the center of the universe. If moons go around Jupiter, then presumably Earth can't be the center of everything. And he made meticulous notes about how these moons work around Jupiter. And hopefully, if the skies stay clear, you'll have a chance of seeing Jupiter and the 4 moons for yourself in just a little while if you go up to the top floor and use the telescopes up there. In addition to looking at Jupiter and its moons, Galileo pointed his telescope at Saturn and was rather confused to find that he got a blob with 2 blobs either side. He couldn't quite work out what it was he was looking at. And indeed, many astronomers who used telescopes in the following decades got very confused as to what the actual shape of Saturn was. In other words, you can see there, was it an object with 2 ears? Was it like jug handles? Was it 3 separate objects? It wasn't until something like 1659 that Huygens said, well, I think I know what it is we're looking at. We're looking at a sphere with a ring around it. In other words, telescopes weren't so good that people could absolutely tell that's what they're looking at. With modern telescopes, it's fairly clear when you look at Saturn. But back in the 1600s, with the quality of optics they had available to them, it wasn't so obvious. But Huygens' idea from 1659, if we look at a Hubble Space Telescope image of Saturn, we realize how close he was to saying that, yep, that's what Saturn is. It's a sphere with a ring system. But it wasn't only Saturn that caused confusion in the early days. Schiaparelli looked at Mars and thought he could see various features on Mars. There's some of his drawings made a little bit bigger on the right-hand side. He thought he could see canali, channels, straight lines. He wasn't trying to imply that they were canals. That was a mistranslation of canali. So he thought that they were channels, but other people picked that up and said, well, if there are canals on Mars, they must be artificial. And if they're artificial, that means somebody must have dug them. So Schiaparelli's original observations, which indicated there seemed to be these channels on Mars, got interpreted by other people, in particular Percival Lowell in America, as, well, if they are canals, they're artificial, and if they're artificial, that means only one thing. There can be no doubt that living beings inhabit our neighbor world. This was the start, if you like, of the idea of War of the Worlds. Martians digging up canals and taking irrigation from the poles to the equator, and Martians look at Earth thinking, well, there's a lot of water on Earth, why don't we go and invade them? So this was Percival Lowell, the greatest authority on the subject, perhaps according to Percival Lowell, but you do realise that science can get things wrong occasionally. Lowell was looking through a telescope, this one in Lowell Observatory. There's a picture of him looking through the end of the telescope. What's thought is most likely with a very big telescope like this, with a big lens at one end and a tiny little eyepiece at this end, you know what happens when you go to the optician to have your eyes tested? A bright light shines in your eye. What do you see? You often see the blood vessels on the back of your eye. Maybe that's what he was looking at. Maybe he thought he was looking at Mars, but in fact he was only looking at some lines on the back of his own eye, not lines that were actually on the surface of Mars. So although Schiaparelli and others said that they could see straight lines on Mars, other people said, well, I can see things, I can see dark things, I can see light things. I'm not convinced any of these lines are actually straight, but yes, there are markings on Mars. So it wasn't long before the early ideas of Mars, which is covered by straight lines and other features, it wasn't long before that gave rise to the modern picture, and here's a Hubble Space Telescope image of Mars, where we clearly have dark areas and light areas, and there are polar ice caps, just like there are on Earth, but there don't seem to be any straight lines. In other words, it was an artifact of the way people used telescopes over 100 years ago. Amateurs love to use telescopes as well, and you'll see some of those on the roof later. They would be, generally speaking, smaller than the huge telescopes that are used by professionals, and some telescopes, like the one on the left, will use lenses, and they're called refractors. Some telescopes, like the one on the right, will use mirrors, and they're called reflectors. And the overlap of these two circles, there are some telescopes which use a combination of lenses and mirrors, and for reasons I'm not going to go into, they're called cats. So there are different types of telescope, and hopefully you'll see a few different types of telescope up on the top floor if you visit them in a short while. Amateurs, just like the professionals, want the largest telescope, usually the largest telescope that they can afford. Why do you want a large lens or a large mirror? Well, it's twofold. One is it catches more light. So you can see fainter objects if you have a larger mirror, because you can collect more light, and hence you can see objects that are fainter. But also, large lenses or large mirrors means that you can see more detail in any of the objects you want to look at. So it's a double whammy. Going to larger apertures, larger lenses, larger mirrors, gives you more detail, and you can see fainter objects. So it's generally something that you always want to aspire to. But ultimately, it depends on how deep your pockets are. Because a small telescope for amateurs might cost hundreds of pounds, but large telescopes, if you've got deep enough pockets, can be truly wonderful. And a telescope like that, I'm sure you can't get the scale, so let me put a person in. You realise that that is a very large telescope, and you'll have to mortgage your house to afford something like that, basically. But some amateurs are very, very enthusiastic and will be prepared to put tens of thousands of pounds into the best telescope that they can afford. It can be a very expensive hobby. It doesn't have to be. If you wish, you can start with observing the sky with binoculars or a small telescope, or you can take pictures of the night sky using whichever camera that you happen to use, and you don't really need anything in the way of more exotic equipment other than the camera you've probably already got at home. So it is possible to take pictures of the night sky and get some wonderful images without investing thousands and thousands of pounds. But if we look at how professional telescopes have changed over the years, in the top left, this is a scale picture of the relative size of the lenses or mirrors of various telescopes, not since Galileo. The top left-hand corner are the telescopes of early last century. The largest lens in a telescope was about 1 meter in diameter. That's the largest lens that you can make. But mirrors, you can make almost any size you like. Notice the large mirrors are actually hexagonal segments. You can make lots of small mirrors and put them all side by side to make up a really big mirror. The largest telescope in the world at the moment is that one at the top, Gran Telescopio Canarias. That's a hexagonal mirror, but it's approximately 10 meters in diameter, rather larger, for instance, than the Hale telescope, which was the biggest telescope in the world when I was born. Not only do we have that as the largest telescope in the world, space telescopes down in the bottom left-hand corner, you notice they're not particularly large compared to some of these mirrors that we see here. That's simply the difficulty of putting one of these telescopes on top of a rocket and sending it into orbit around the Earth or into a particular location in space. We would love to have a big mirror in space, but it's just too awkward to do that. So we have to put up with relatively small mirrors if we want to put them into space. But on the ground, there's almost no limit to how large we could make a mirror if we really wanted to. There's the rather oddly named extremely large telescope. As I say, these people are very bad at naming things. When they built a big telescope, they called it the very large telescope, and then they realized they're running out of adjectives. So we really then move on to the extremely large telescope. What the next one will be, well, who knows what adjective they'll come up with that one. So this one, the Hale telescope, when I was born, this was the largest in the world, and it had a mirror 5 meters across. There were no people in this particular picture, but perhaps you can get an idea of scale from this ladder in the background. So you can see, even though it is nearly 75 years old, this particular telescope, built in the middle part of last century, it is still a giant. It is still an absolute behemoth of a construction. But where are these big telescopes? That one was in California, but these days, the best observatory sites in the world, if you're going to build a big telescope, you want to put it in the best observing site in the world, and there are essentially 3 of those. Hawaii, and so there's a lot of telescopes on the islands of Hawaii, on top of the volcano. The Canary Islands, again, volcanoes, really good for putting telescopes on. They tend to stick up above the clouds, so you can observe, even when there's clouds down at sea level, you can still observe a clear sky. So La Palma and Tenerife in the Canary Islands are favorite places to put telescopes. And finally, the Atacama Desert in Chile. Again, a very high location above a lot of the Earth's atmosphere, very good for seeing conditions. Let's just have a quick look at what that looks like. If we have a look at one observatory site in Chile, that's what a typical mountain observatory looks like these days. It's one observatory taken from the neighboring mountain where there's another observatory. So you can see these are very remote, very isolated, a very difficult dirt road to get up to the top of a mountain. It's very difficult to get equipment up there. It's rather difficult to get people up there. But if you want the best seeing conditions, you stick your observatory on top of a mountain because you're above most of the Earth's atmosphere, which can absorb, and a little bit of turbulent atmosphere can distort the images that you're trying to get of either the solar system or the rest of the universe. If the top of a mountain isn't high enough, you can go a little bit higher than that by putting your telescope in the back of a 747. And yes, they have done that, yes. This is SOFIA, the Stratospheric Observatory for Infrared Astronomy. For quite a few years, they flew this infrared telescope in the back of a 747, flew it at 10,000 meters or so, again, above a lot of the Earth's atmosphere, so that the infrared was not absorbed too badly. But of course, if you want to go higher than a 747, well, ultimately you put it into Earth orbit. And then we're back to the Hubble Space Telescope, launched in 1990. It's been in use for the last 35 years and is still producing excellent data and excellent images. More recently, the James Webb Space Telescope, instead of working in the visible part of the spectrum, the James Webb works in the infrared, longer wavelengths of light, so we see different things. The Webb telescope was built on Earth, and then because of the very large mirror, it had to be folded up. So the little bit of origami was required to fold up the telescope so it actually fitted on top of a rocket, and then it was launched on Christmas Day 2021. And then it was operational a few months later, and it's been producing some wonderful images for the last 3 years or so. If we compare James Webb with Hubble, the James Webb has got a larger mirror, but it works at different wavelengths, so it turns out the amount of detail you can see in these images are very similar. But notice that what you see in visible light, this is how you might see Jupiter. If you can see Jupiter in a big telescope, you might be lucky enough to see an image a little bit like that a little later on. In particular, you should be able to see the horizontal belts or banding of Jupiter. These are different winds that are moving in different directions and churning up different compounds in the atmosphere of Jupiter. If we look in the infrared, it looks a little bit different because different compounds, whether it be sulfur or phosphorus or ammonia or other materials, will absorb light differently in the visible part of the spectrum compared to the infrared. Notice also we see this little bit of a red at the top and the bottom. That's not because the telescope isn't perfect. That's because we're seeing aurora. We're seeing the northern lights and the southern lights on Jupiter, just like we can sometimes see the northern and southern lights here on Earth. You might have seen the aurora borealis recently when for a number of times they were visible from the UK. Here we're looking at aurora on another planet. If we compare what the Hubble sees of Saturn, again, that's a nice view of Saturn. Unfortunately, Saturn isn't visible tonight. It's going to be below the horizon, so you're not going to get a telescope view of that this evening. But there's a nice Hubble picture of Saturn. It's quite surprising to realize that what James Webb sees when it looks in the infrared is rather different. The Saturn itself has got a lot of methane in the atmosphere, which absorbs infrared, and so we don't tend to see much glow from the Saturn's globe itself. But the rings, by comparison, look very bright. The rings are lots and lots and lots of tiny ice particles that are all going around the planet independently. The rings are not solid, they're just lots of objects orbiting the planet. And they are lots of small particles of ice, and they reflect infrared very strongly. So unlike the globe of the planet, they reflect nice light very clearly, whereas the planet itself absorbs at this particular wavelength of infrared. So we get a rather odd view of Saturn. And the same is true of Uranus as well. Uranus has a ring system. It's a relatively weak system when we look at it in visible light. It doesn't seem very bright at all, but in infrared, because the planet itself is a little dimmer, the rings show up very brightly in a James Webb Space Telescope image of this planet. Seems to have a storm system raging. A very bright spot on the left-hand side indicates that it looks like a storm is raging on the planet at the moment. If we go one planet out to Neptune, the same sort of thing is true. It looks like Neptune is quite bright, but actually Neptune is not so bright, which is why its moon, Triton, this is the brightest moon of Neptune, the moon looks like it's brighter than the planet itself. That's simply because the planet absorbs a lot of infrared at this particular wavelength, and the Triton moon is actually reflecting its solid nitrogen, and it's reflecting a great deal of light, and hence it tends to look very bright. But notice Neptune has rings as well. So although we associate Saturn as the ringed planet, actually rings are not that uncommon. Basically, a lot of big planets, Jupiter, Saturn, Uranus, Neptune, all of the really big planets in the solar system have ring systems. It's only small planets like, for instance, Earth, that is too small to have a ring system of its own. What's coming up next? Well, there are interesting telescopes under construction. The next few years are going to be really exciting in terms of what's going to be coming online. Under construction at the moment is this telescope. Goes by the rather awkward name of the LSST, the Large Synoptic Survey Telescope. Basically, it is a very large camera with a huge mirror, 8 meters in diameter. The camera itself is going in this area in front of the mirror, and to give you a sense of scale, there's the camera with a standard person standing next to it. So the camera is absolutely huge, and the camera, when used in the telescope, is going to be able to survey the sky. It has a very large field of view. Unlike the Hubble Space Telescope, unlike the James Webb Space Telescope, which can see incredible detail but only in a very small patch of sky, this telescope is a survey telescope. It'll be able to take large chunks of sky, and in one night it'll be able to cover a huge chunk of the sky above it. It will only take a few nights for it to effectively map out the whole sky, and it will map out the sky day after day, night after night after night for 300 and something nights. It's very good seeing conditions in Chile, which is where this is based. So for maybe 300, 320, 330 nights of the year, it will be taking data, imaging the sky over and over and over again. So it will be effectively taking an inventory of everything it can see in the solar system, everything it can see in the Milky Way galaxy, and all the other galaxies that are out there. It will end up cataloguing billions of stars and billions of galaxies, as well as who knows how many thousands of objects in the solar system which we didn't actually know were there until we take the survey. So this survey is going to be a 10-year survey, perhaps not starting this year, maybe it'll be next year. Hopefully it'll be calibrated this year, and by next year or thereabouts it should start its 10-year program of taking data over and over and over again and telling us what is out there and what is changing. Are objects moving through the solar system? Are stars changing their brightness? Are galaxies changing? Are supernovae going off? Are stars exploding? In addition, there's a really big telescope coming online. I mentioned this one earlier, the European Extremely Large Telescope. Terrible name, but it at least describes what it is. And if you're having trouble with the scale, there's a couple of people right at the bottom there. And there's a couple of people on the gantry. So it really, really is a monster. It's the size of a building, or like the size of a big building. The mirror is something like 40 meters in diameter. And it's currently under construction on a mountaintop in Chile, being built by the Europeans, which includes the UK, because we are part of European collaborations, even if we're not part of the EU. And so this is being put together, and it won't be long before this telescope is operational. And with a mirror that size, it'll be able to see even the faintest of objects, whether they be distant galaxies on the other side of the observable universe, or whether they're the smallest objects in the solar system, which at the moment we struggle to see, simply because we can't collect enough light. When we have that collecting area to collect the light, we should be able to see even the faintest of objects. So the next few years are going to be really exciting. A survey telescope to tell us what's out there, and then big telescopes like this one to follow up and look in detail at solar system objects and objects elsewhere in the universe. So I've given you an idea of what telescopes are being used and what telescopes are coming online. If you want to know more about what the Hubble Space Telescope is doing or what the James Webb Space Telescope are doing, there's a couple of web pages that give you more information. And if you want to know about the telescopes that will be coming online soon, there's the LSST and the ELT, the Extremely Large Telescope. Don't worry about making a note of these particular web addresses. I've got them printed on a separate sheet if anybody wants to take those away with them. Thank you very much for listening.